when we have taken the case when both the numerator and denominator are positive. Let us take the case when both of them are negative. So we can write 1 minus x is also less than equal to 0 and x is also less than equal to 0. So let us try to understand here what the solution set will be. So again, let us have the number line. Here from the first inequation we have x should be greater than 1, which means if we have 0 here and 1 here, we need to have a solid circle at 1, and then all the numbers which are greater than 1 will satisfy 1 minus x is less than equal to 0. Let us now take the case when x is less than equal to 0. Now from here we find that 0 is certainly included and all the numbers on the left hand side of 0 will be included, which means if you look at both the solutions, and since both have to be simultaneously true, there is no common value for x which is going to satisfy both these conditions, and hence for this x belongs to null set. That is to say, we can write this as x belongs to phi for the case 2, and hence if we have to write the answer for question number 1, our solution is therefore solution set for x is x belonging to open interval 0, closed interval 1. So this is the answer to the first question. So on solving the first question, we found that we get an expression like 1 minus x upon x is greater than equal to 0. Now, solving this inequality was easy because here only two factors were involved, 1 minus x and x. But what if we have an expression like this, or like this, or like the third one that we have here, or in general, let me write an expression here which is x minus 2 upon raised to the power 4 into x plus 1 raised to power 3 into x plus 2 divided by x minus 5 whole square greater than equal to 0. So if we have a situation like this, then it becomes really complicated to analyze the cases when which factor would be positive or negative in such a manner that our such situation on the totality is satisfied. So trying to understand the inequality and solving this, we need to use a wavy curve method. So let us now discuss the method which is known as wavy curve method. Now, using this method, we find the solution set of such inequalities. So let us first discuss this inequality using wavy curve method. So how do we solve this inequality? So the first step here is to figure out where all these factors become 0. That is to say, we have to find the values of x where x minus 2 becomes 0, x plus 1 becomes 0, x plus 2 becomes 0, and the last and the remaining term that we have inside the bracket, x minus 5 becomes 0. Now if we solve these four, we find that x is equal to 2 in the first case, minus 1 in the second case, minus 2 in the third case, and 5 in the fourth and the last case that we have here. After we have done this, the next step is to draw a numbered line. Let us now mark all the points that we have here. So minus 2 is the smallest. Let me take minus 2 here. Minus 1 would be here, let's say 0, 1 and 2. And let me take 5 to be somewhere here. Let us extend the number line on the right side a bit. So what we have done is we have found all the points where these bracket terms become 0 individually, and we have marked them on the number line. Now we take in general any point lying on this number line and try to put the value here in this expression and figure out what is the sign for that particular value. So let us say we choose a number 0 which lies in between minus 1 and 2. If we put x equal to 0 here, we find that minus 2 raised to the power 4 will become positive. This will become 0 plus 1 cube will also be positive. Here will be 0 plus 2 positive again. 0 minus 5 is going to be minus 5, but when squared it becomes positive. So for the value x equal to 0, this expression is going to be positive. So let us put a positive sign here in between minus 1 and 2. Next is to take a value lying in between 2 and 3 and figure out the sign, and then we'll put the sign over here. Same is the case for minus 2 to minus 1. And after that, we also need to do the same method for all the points lying between 5 and infinity. So for here, we can take any number, let us take 6. So if we take a number 6, this is going to be positive. X plus 1 is positive, x plus 2 is positive, and x plus 5 is also positive. So here also we have a positive sign. So this is how we select a particular number which is convenient for us to decide whether the resultant answer will be a positive or a negative, and then we put the signs here. Now there is a shortcut way of doing this, putting up the sign. So for understanding how do we do that, first let us take the term x minus 2 raised to power 4. So basically from here, if we put x equal to 0, we get the solution x is equal to 2, which is this particular point. Note it carefully in the diagram. Now since the power of this factor, which is x minus 2, is positive, the sign on both sides of 2 is going to be positive. It is going to remain the same. So since we have found that on the left side the sign is positive, again the right side also will have a positive sign. Now clearly we have, if we want to look at point 5, the value of x where x is equal to 5, here again we got x equal to 5 from the factor x minus 5 whole square, which has a square power. So again the sign is going to be positive on both sides, or to say the sign is going to be same on both the sides. Let us now look at the term x equal to minus 1. So x equal to minus 1 was a term which we got from x plus 1 equal to 0. Now here the power is odd. If the power is odd, the sign will change. So if we have a positive sign here, in between minus 1 to minus 2, the sign will be negative. And let us look at the last one at the point minus 2. Here also the sign is odd, sign will again change, and since here on the right side of minus 2 we have a negative sign, here we will have a plus sign. So let me write the solution set for this particular inequality. We have found that in these intervals, that is in the interval minus infinity to minus 2, since we have an equal to sign, we need to have a closed bracket here, and then minus 2 to minus 1 will not be included because the sign is negative here. That is to say, the values of the expression for all x in between minus 2 to minus 1 is going to be less than 0, which our situation or the given condition does not satisfy. We do not have to include that. Again, the next solution set will be minus 1 to 2. In fact, minus 1 to infinity, if we write them separately, and hence if we got to write the complete solution set, we can simply write x belongs to minus infinity to minus 2 closed interval union minus 1 to infinity open. So this is the solution set for the first inequality that we have. So what you need to remember is the following. First, you need to put each of the bracket that is given in the question equal to 0. Mark those points on the number line. Take a convenient value of x. Generally, we take x equal to 0 because calculating the value at x equal to 0 is very easy. After we have figured out the sign, which is whether it is positive or negative, we just change the sign accordingly. If the power is even, the sign remains the same on both sides. If the sign is odd, it changes. Now here you might have a question that we have not checked the sign in between x equal to minus 2 to minus 1. So let us do that. So let us take the value of x is equal to minus 3 upon 2, that is minus half. Now this is anyway going to be positive, so it does not bother. The denominator also is of, it does not bother. But in the numerator we have even powers, so that we need to consider properly. So minus 3 upon 2 plus 1 is going to be minus half. Power 3 will give us a negative answer. Minus 3 by 2 plus 2 will be positive, and hence negative into positive has to be negative, and hence we have rightly put a negative sign over here. So we have also checked that the sign that we have put using the idea that if the power is odd, we need to change the sign, and if the power is even, we need to have the same sign on both sides is correct. And we have also verified. Now here we have missed out on one important thing, and that important thing is the following, the denominator. Now look at the solution. This solution includes 5 as a solution set, but if we have x equal to 5, this expression is not valid. It becomes undefined, because if we have anything, in the numerator, but in the denominator we have 0, it is not going to be defined any further. So we need to exclude 5 from the solution set. So this is how we can write the answer, or if we want to write it together, we can write it in the following manner as well. Minus infinity to minus 2 closed union minus 1 to 5 open union 5 to infinity. So this is other way of writing the solution, and you understand that both of them represent the same solution set, and hence both of them are correct. So this is how we approach and proceed solving inequalities using wavy curve method. Now if you remember, we found that in the first case, the solution that we had was x belonging to open 0 and closed 1. So let us try and understand and check and verify wavy curve method for our first equation. So inequation rather. So if you look at this question, so here is our answer using wavy curve method to the question 1. So here we have 1 minus x in the numerator and x in the denominator. So if we put these two factors as 0, we will have x is equal to 1 and x is equal to 0. So let us now draw a number line first and mark these 2 points, 0 and 1. Clearly, since x is in the denominator, x equal to 0 cannot be the answer. So we need to put a hollow circle at x equal to 0. Now here, since there is an equal to sign, we need to put solid circles at x equal to minus 2, minus 1, 2. Only we have a hollow circle at x equal to 5. So here, if we move on to this first question, now let us check the sign. Since we need to check for these 3 portions, let us first take the value of x as 2. If we take x equal to 2, we have the sign as 1 minus 2, which is negative upon positive. So here we have a negative sign. Now since 1 minus x is raised to power 1, which is odd, the sign will become positive on the left part, and hence we have to put a positive sign, and again power of x is 1, so again the sign will change on the left and right side of 0, so here we need to have a negative sign, and if we just write the solution in this case, 0 is not included, 1 is included, and hence this is the solution set in the first case. Now you might understand that this is much easier to solve and understand than the method which we first tried using when we considered both of them to be positive, both of them to be negative. So this is how we solve questions related to inequality when we have a lengthy expression and it consists of many factors. Let us now similarly proceed and see how we can solve question number 2. So here is our answer for question number 2. So rather this is second part of the first one. Now here it is rather simple question. It is x minus 1 whole cube into x plus 1. This is supposed to be less than 0. So if we put x minus 1 equal to 0 and x plus 1 equal to 0, we get two values of x. One of them is 1 and the other one is minus 1. So let me put a number line here. Let me take minus 1 and 1. Now since we have only less than sign, there is no equal to sign here, both these points will be open circles because these values will not be included in the solution. Now let us check for the sign. Certainly 0 is a very convenient option for us. So let us put 0. 0 minus 1 whole power 3 makes it negative, into positive is negative. So here we need to put a minus sign. We are putting minus below and positive up on the number line. Now since the power of both the factors that we have x minus 1 and x plus 1 are odd, the sign is going to alternately change. So since we have a negative sign here, on the right side of 1 we'll have a positive sign, and on the left side of minus 1 we'll again have a positive sign. So the solution set in this case would be x belonging to open interval minus 1, comma 1 and open interval again. So this is how we need to approach questions related to inequality using wavy curve method. Now here there is another interesting point to be noted. Now if you look at this expression or any expression, if the coefficient of the highest power of x is positive, the right side, the first interval that is present on the right hand side on the number line is always going to be positive, because since if you look at this expression here, the highest degree of x is 4, which means that x raised to power 4 is having a positive number, positive coefficient, and hence we have a positive sign on the first interval on the right hand side for obvious reasons, because if we have x to the power 4, if x is very large, positive number is multiplied to x and x raised to very high power now if we have x to the power 4, now since if x is very large, x to the power 4 will become very large, and since the sign for x to the power 4 is positive, it is certainly going to be positive, and hence the conclusion that in the first interval, which is present on the right hand side, will have a positive sign. Now that we have discussed these two questions, let us quickly move on to the third question here. Now here we have two inequalities. The first one is 5x minus 1 is less than x plus 1 whole square, which is again less than 7x minus 3. Now here we need to have such a solution which is for which all these conditions are satisfied. So let us try to solve them one by one. Let us first take these two. So we have 5x minus 1 less than x plus 1 whole square. Let us try to solve them. So we have x square plus 1 plus 2x, which is the expanded form of the right hand side, this minus 5x minus 1 has to be greater than 0. So this is the first inequation that we have obtained. Now from here we can find x square plus 2x minus 5x gives us minus 3x, and then we have minus minus plus, so plus 1 and plus 1 makes it plus 2 greater than 0. Now definitely this is a quadratic which can be written as x minus 1 into x minus 2 greater than 0. So if we want to find the solution set for this inequality, let us have a number line. On putting x minus 1 equal to 0, we get a point x equal to 1, and on putting x minus 2 equal to 0, we get x equal to 2. So these are the 2 points that we have obtained. Now since we have only a greater than sign, hence we need to have an open circle at these 2 points. And let us now check for the sign. Since the coefficient of x square, which is the leading term in this case, is positive, so on the right hand side we'll have positive sign, here we'll have a negative, and here we'll have a positive. Let us check for the sake of verification. Let us put x equal to 0. So 0 minus 1 makes it minus 1, into 0 minus 2 makes it minus 2, minus 1 into minus 2 is a positive number, and that is how we have a positive sign here. So our method is correct. And since the power of the term x minus 1 is an odd number, hence the sign changes. From plus we have a minus, and since again the power of x minus 2 is an odd number, the sign again changes and we have a plus on the other side. So this expression, that is x minus 1 into x minus 2, is greater than 0 for x belonging to minus infinity to 1, both of them open-ended, union open to infinity. So this is the first solution when we have considered only this portion of our inequality. Now let us now take the inequality where x minus 1, x plus 1 whole square is less than 7x minus 3. So on solving that, let us see what do we have. So we have x plus 1 whole square minus 7x minus 3 is less than 0. So let us expand this. On expanding, we have x square plus 1 plus 2x minus 7x plus 3 is less than 0. So from here, we have x square minus 5x plus 4 less than 0. Now here, this again can be written as in terms of 2 factors, x minus 1 into x minus 4 less than 0. So here again, let us take the help of VV curve. So let me first draw the number line. The points that we have here is 1 and 4. So let me mark 1 here and 4 here. Since again the sign is only less than sign, we need to have a hollow circle, and let us check for the sign. Now since again the coefficient of x square, which is the leading term, is positive, here we'll have a positive sign, and here negative, here positive. You can again go and check if by putting the values if these signs are correct or not, and hence if we write the solution, now this portion has to be less than 0, means it has to be negative, and negative is when x lies in between 1 and 4. So here the solution is x belonging to open interval 1, 4. Now, so these are the 2 conditions that we have obtained. Now look at these 2 solutions carefully. Here we have x should lie in between minus infinity to 1 and 2 to infinity. And here we have found that x should lie in between 1 and 4 in order that second part of the inequality is valid. And hence, if we want to have a solution which is valid for all or for throughout this inequality, then the answer should be x should belong to 2 to 4, because this is the portion which has an intersection, which has a common solution, and the part which is on the left hand side of 1 does not have any common solution with the second answer that we have, and hence our answer to this question is 2 to 4 open interval on both sides. So this is how we study wavy curve method and how we solve questions related to inequality.